with computer audio. Testing 1, 2, 3, 4. Can everyone hear me? Is that working? Okay. Cool. Can everyone hear me? Um, can people hear me? Just send me a message if I'm okay. Mo can hear me. Cool, because I'm not seeing any function on my recorder, so I don't know if it's recording or not. Okay, cool. So, right, guys, welcome back. Another arduous week for me. Geez, a bit of a busy week. We're busy doing a fence expansion on the southern end of Tula, adding another 500 hectares on. But it's hilly area, so it actually works to be quite a bit more than 500 hectares. And it's absolutely magnificent, very forested, riverine area. We'll have ample space. I'm planning to bring in some red dacres. And we're going to try to bring some reedbuck in as well to expand the biodiversity of the reserve. It's also just nice to be protecting the area from a lot of poaching and human encroachment. And the more area we take up for conservation, the more we protect it from people. How long that will last, who knows? But cool. Okay, so we've got quite a small group tonight. That's fine. It comes and it goes. So we're going to get straight into the party. We, as promised, we are starting off with our elephants. And away we go. Okay, so we are doing the Afrotherians, which, if you remember a long time ago, I remember Afrotherians include elephants, dassies, dugongs, the tubular Titans, which are your aardvarks and all those guys, but we'll get into that today. So, the book of the week, very relative to the topic at hand, The Living Elephants by Sukamar. Very good book. I managed to find a copy of it in hard copy and in PDF. If you can find it, it's really worth buying. It's a little bit pricey, but it's a tome of knowledge. It's about 800 pages. It's really worth getting. The best elephant book you'll ever get in your life. An in-depth understanding of elephant ecology for both Indian and Asian elephants. And how they contrast with two different species, and of course their evolution. So, Afrotherians, literally African. So, Afrotherians quite literally means African beasts, and they're a highly diverse group. Now, obviously, when you hear that, people think straight away lions and leopards and rhinos, but as you guys have seen, those animals evolved in other parts of the world. They did not evolve in Africa. They diversified and spread in Africa, but their roots, for instance, rhinos' roots are in America, the cats are in Asia, and so on and so forth. So we're not going to be worrying. When we say African beasts, do not think of current African beasts. We're talking about their evolutionary heritage. And they're a highly diverse group and full of really weird animals. While little remains to show the current physical similarities, the fossils, there are very few fossils for some of these species, but what we have managed to do is do the genetic studies, and that links a lot of the evidence. For a long time, we linked these animals with other relationships because we didn't have genetic studies, and there weren't many fossils. And all of a sudden, genetics came out in the 80s and 90s, complex genetic studies, and we discovered things that we were just completely unaware of. For example, they used to link aardvarks with pangolins, and then they realized they're completely unrelated. Pangolins are actually more related to cats, strangely enough, but that's another story. And aardvarks are more closely related to the elephants of the two. Afrotherians share numerous cases of evolutionary convergence with other mammal groups, and that was because a lot of these animals did not occur in Africa. For instance, we didn't have high rodent diversity because Africa was isolated. We didn't have any of the browsers or grazers that Asia and Europe had, and the Americas had, because they just didn't evolve here. So the Afrotherians took up a lot of those ecological roles. So all Afrotherians, all their ancestors, evolved in Africa, and they've dispersed all over the world over time. For example, Asian elephants, they're in Asia, but their roots are in Africa. So let's go back quite a while. The Cenozoic is the modern area that we're living in, modern animals, and we need to understand how the world looked 50 million years ago to give you some perspective. It's a little bit different to what you can still recognize the world. If you go back 250 million, you wouldn't recognize it. You think it's a different planet. But 50 million years ago, the Middle Eocene, you can kind of see what the world looks like. So you can see the South Atlantic, you can see the Falklands Plate over here, Antarctica and Australia were very close together. New Zealand was actually over here. Yeah, and then all these Pacific Rim plates and islands were all messed up. Asia was a hodgepodge mess. There was the Tethys Sea in between the India and the Indian Ocean. India had not crashed into the Himalayas yet. North America and South America were still separated except for a string of islands, and Africa and South America were quite close. And Africa was, like Australia, one large continental island. Nothing could get in, nothing could get out. So a lot of the other animals that evolved in other parts of the world never got an opportunity to arrive there until much, much later, 25 million years ago. If you're looking at the world 14 million years ago, you can see that the world is more or less on the lines of what we recognize it to be. Okay, Europe is a little bit different, but everything is more or less where it should be. Antarctica has sunken further south. Australia has come further north. The Falklands Plate has basically disappeared. North and South America are mostly connected. That only really happened about 2.5 million years ago, the real connection that we have today, Panama. And a series of seas and islands made up Europe, and that all changed with geological activity over the last 10 million years, but more or less intact. And Africa, for all intents and purposes, had connected with mainland Asia. So, understanding that Africa was isolated, it created its own little brewing pot for a variety of organisms to come up and take up roles that didn't occur or they were available, but other animals weren't taking them up. For example, rodents, shrews, moles, and all these other things that didn't occur in Africa. So modern Afrotherians are broken into two groups, or clades as we call them. The Pangulata, which are the almost ungulates. Now remember, they're not related to ungulates in any way. They just happen to look kind of similar. And these are all herbivores. They're descendants of the Hyraxes, or Hyraxes, dassies as we call them. And the other ones are literally the Afro-insectophyla, the African insect lovers, or insect eaters, which are all insectivorous. Very simple. So Afrotherians are broken into herbivores and carnivores, but the carnivores are not eating chunky meat, they're eating little insects. So again, you're getting the same sort of patterns occurring in nature all over time. So we're going to be focusing specifically on the almost ungulates for quite a while because there's a lot of ground to cover, and we'll get to the insect eaters much, much, much later and quite a few lessons. So the modern year ungulates all share similar features, such as they have similar cavities in the skull. I'm sure we all know elephants have cavities in their skulls, but you didn't know that dugongs and dassies also have cavities in their skulls. They have very similar hip structure. Their foot structure is almost identical, and you'll see with some of the fossils, it's amazing how similar the fossils are to modern elephants. And they have extremely similar dentition. This is, again, very important. Dentition is one of the things preserved in the fossil record, and we can do a lot of studies just by looking at the teeth. We know more about human evolution from the teeth than anything else, because it is one of the best preserved things in our fossil record. And in the 1990s, when genetic studies really took to the fore, we reconfigured so many of the classical relationships that we had, and we scrapped so many things off the table, and we got these guys together because we had no idea they were related. They didn't, obviously geological studies were also, even in the 1990s, are not as accurate as they are now. That was nearly half a century ago. It was 30 years ago. So yeah, it's, science is a constantly evolving subject. So things that we even know now might be wrong in the future, but we don't discredit it until it's proven wrong. But the evidence so far presents the current statement. So currently there are 3 living orders of the herbivorous almost ungulates. We're not looking at the insect eaters, remember. They're the Hyraxes, the Hyracodeers, the Proboscideers, which are the elephants, which are quite limited in number, and the Sirenas, which I love that name. It's my favorite order name, which are the dugongs and the manatees, literally the sirens from the Greek mythology. Awesome name. Okay, so they have very similar features, and we're not going to get into the details because that's a 20-year study and a thesis that none of us need to do, but just go through the basics. They have very primitive foot structure. I'm sure you've all seen the elephant's foot structure, but dugongs and dassies have those structures as well. They're a little bit modified, or the elephants and the dugongs are more modified, but they have a very similar primitive foot structure, almost plantigrade in its behavior. They have very simple digestion. It's a sac stomach, not complex like a ruminant or even like a perissodactylon, a horse or a rhino. It's actually very primitive. And they have continually growing canines. In many ways, similar to a rodent, there's a bit of evolutionary convergence there, but with rodents, their sizes. With the Hyraxes, it's actually the canines that are continually growing. So a little bit different, but the same sort of pressures and the same sort of behavior. So going back 60 million years, this is 5 million years after the extinction of the dinosaurs, we had a very small rodent-like, when we say rodent-like, looked like a rodent, wasn't a rodent, Hyrax, which is called Osapia Dioensis. Say that 3 times. And he was a small little guy, about yay big, about 30 centimeters. And very poorly preserved fossil, but he's the earliest known ancestor of all modern Hyraxes. And modern Hyraxes, as we start to find them, they're actually a very ancient species, and they've remained relatively unchanged for 55 million years. And the first ones appeared around 55 million years ago, and they were extremely diverse. They were big ones. They were runners, very similar to gazelles and antelopes. They didn't have horns. They were hippopotamus-like ones. They were ones that were very almost primate-like in structure. They were small ones the size of rodents. They were extremely diverse, and they occupied every conceivable niche. And this was before our ruminants came to Africa, and primates really started kicking up the gears, and rodents really started infiltrating Africa. So these niches were all taken up by the Hyraxes. And we don't realize that Hyraxes were the kings of Africa for a good 30 million years. As even toad ungulates gradually dispersed into Africa, remember, 50 million years ago, Africa was not attached to the rest of the world. By about 30 to 25 million years ago, it was starting to become attached to the mainland Asia. About 14 million years ago, it was firmly attached. So ignoring, obviously, changing sea levels. But this allowed a lot of the more complex ruminants and other species and odd-toed and even-toed ungulates and all the various other animals, the predators, to actually infiltrate into Africa and create competition for the Hyraxes. And many of these Hyrax species just went extinct. They just were not as good as the ruminants. They weren't even as good as even the odd-toed ungulates, the horses and the rhinos' ancestors, and the predators that just flocked in and just ate them to pieces. So they basically lost out on a lot of the habitat that they used to have. So they went one of 2 ways. They either got smaller, a lot smaller, as in the size of dassies as we know them today. The ones that were the size of rodents just simply got outcompeted by the rodents. The rodents were just better. So they found a niche that works for them today, and they stay there. Nothing in Africa really competes with where dassies are today. They live in rocks, and they live in cliffs, and they live in trees. Nothing really gets in their way. So they found their niche. Others got bigger, a lot bigger. So large Hyrax species gradually became either smaller or became more adapted to aquatic conditions. So the large ones all became very aquatic. It was a great place to be. You stayed in the water. At that time, there were no hippos in Africa. So they were pretty much these large, almost capybara type animals. If you can imagine a capybara from South America, an African equivalent of that, a dassie, being about that size. And these were the early proboscideans. These were the early ancestors of elephants. So this is a modern Hyrax skull. And this over here is Titanoharax. And Titanoharax was the size of a very large pig. And now we're talking, so you can see 50 centimeters over there. He would have been about 2.5 meters long and probably about 1.5 meters tall. And that was Titanoharax. He was an absolute beast. And he was, we obviously don't know what he looked like in terms of coloration, but we know from the skeletal structure that's what he looked like. He was a rather robust boy. And he existed from about 50 million to about 30 million years ago. There were numerous members in his genus, and gradually he started specializing, or he was one of the many members that started specializing in more aquatic conditions, and eventually evolved into this species called Afrotherian. He first appeared in the fossil records, early versions of him, about 35 million years ago. Remember, there's no sudden flip the switch from one species to another. There's a gradual shifting from one species to the next species. And these were these species over here. They were very hippo-like in appearance, very comparable, had the same ecological structures, solid bones. They had a lot of things that you would easily confuse them with hippos, actually. And if you look at the skull of a Moiratherium, you would even mistake this in many ways from the ancestor of a hippo, the same sort of dentition. But, categorically from a lot of the structure of the dassies, that they were very, very closely related to dassies, from the foot structure as well. And so they were hippo-like dassies, and they dominated the riverine conditions of Africa when the savannah and the grasses and the jungles got taken over by all the other animals that infiltrated from Africa, from Asia, and from Europe. These guys stuck to the water, and they stayed there for quite a while. Now, if you look at a Hyrax skeleton, we're going to come back to Moiratherium in a minute, but we're staying with Hyrax for a few minutes. If you look at a Hyrax, in many ways, you can almost mistake this for a mongoose skeleton, the same sort of bulge, the same sort of structure, and a leaping, bounding structure that makes it ideal for hopping from surface to surface. Remember, you'll find with straight-backed animals, they tend to be more plains animals for longer strides and, for more mechanical running, whereas these guys are more bound for bounding. And you'll see the same sort of bent back in your ungulates as well, and dakias, and yalas, kudus, they all have those hunchbacks. And mongooses, also being bounders and jumpers, tend to have hunchbacks like a spring. So we know this guy, looking at a structure at the back, we would tell what type of habitat he lived in. If you find a straight back dassie, you would know that he was more of a plains dassie. He wouldn't be a bounder, he wouldn't be a jumper, he'd be a runner. So we're not going to go too much into the fossils of dassies, but we might touch on it again in the future. Currently, there are 3 genera and only 4 species. Some people say 5 species. It really depends on how you define a species. But there's the southern tree southern tree Hyrax and the eastern tree Hyrax. Some people say they're the same species. Some people say they're different species. There's also the yellow-spotted rock Hyrax, which is found throughout Central Africa, and the rock Hyrax, which historically had a distribution throughout Africa, throughout Southeast Asia, throughout Saudi Arabia, and throughout Southern Europe. He's been extirpated from Southern Europe. It used to be prolific throughout Spain. In fact, the historical name for Spain possibly actually might mean home of the Hyrax, because there were islands that used to have high numbers of Hyraxes on them, and they've all been eaten out, unfortunately. We'll go into a bit of the story about that later. So rock Hyraxes are thriving in Africa, particularly in the Cape, but they still occur throughout parts of Saudi Arabia. They've been mentioned prolifically in the Bible. Fun fact, they're not considered to be, what's the word I'm looking for? Kosher, because they don't have cloven hooves. Apparently, that's in the Bible. Who thought you knew that? I eat a dassie. But anyway, moving on. So, other members of dassies, remember we talked about evolution, convergence, and habitat. There was this fun little fellow over here called Umbrethopoda, not a rhino. Looks very similar to a rhino, but a very similar foot structure to an elephant. And again, very similar dentition to a dassie. So this was a highly modified rhino-like dassie. That was the size of a rhino. And he occupied Africa. He was very successful. For about 30 million years, he was one of the big rhino-like creatures of Africa. And this is what he looked like. And again, you would say this is a cousin of a rhino, but he was a cousin of a dassie. Another fellow that we had was Desmostala, which was around from 13 million years ago. And again, he was probably a descendant of Moiratherium, but obviously with genetics, it's a little bit hard to tell because these are fossils and not bones. So Desmostala would have looked like this. And again, very similar hippo-like structures. The same sort of teeth as a hippo, that large, robust body, solid bones, and vocal network that would have allowed them to sing songs underwater and so forth. So again, we have this thing called an evolutionary convergence, where nature's pretty lazy and the same sort of habitats are created in nature, and because of the same sort of habitats are created, the same sort of organisms evolve to take up those roles. Now, so these 2 fellows have gone extinct, obviously, but with the modern descendants of the dassies, we have the sirenas, which are the dugongs and the manatees. They're still going. We'll do a class and then probably next week a little bit as well, which are pretty weird looking. And again, very similar foot structures to the modern elephants. And the proboscideans, or the elephants, which are still going but have been hammered. So what you'll see again with elephants and tapirs, again, the case of evolutionary convergence, it's a pretty good idea, apparently, to have a fused upper lip and to have a fused nose. And they're not related at all. And so tapirs and elephants, another case of convergent evolution. So both dugongs and elephants share an aquatic heritage stemming from Moiratherium. Remember that fellow that looked very much like a hippo. So Moratherium was around 35 million years ago. Elephant aquatic origins are still very apparent, and people don't realize how aquatic in their heritage they actually are. So in their embryonic development, they have pneumatostromes, which on their kidneys. No, sorry, not pneumatostromes, nephrostromes on their kidneys, which is only found on freshwater animals. By the time they're fully developed in the womb and they are given birth, they lose these. They're no longer functional, but during the embryonic stage, they still have this. Okay, and it's only found in freshwater creatures. That animals that live in almost, even hippos have these. It's a filtration device in the kidneys. I'm not sure exactly how it works. You can ask a zoologist. Okay, they vocalize in the same way that hippos and whales do. And again, we obviously don't know how well that other, remember there were even rhinos that were evolutionary equivalents of hippos. We don't know if they would have been able to do the same, but we hypothesize that it probably would have evolved because they live in water conditions all the time. So male elephants have internal testicles. They don't have a ball sack, so you can't kick them. And this is something that only aquatic mammals have, or animals that evolve from aquatic ancestry, even though they may not be aquatic anymore. So again, we know that they have an aquatic ancestry because if you had external testicles, you wouldn't be able to regulate those temperatures and you would become sterile. So having internal testicles when your body's able to regulate the temperature, far better. If you're a permanently land-based animal, your body can regulate the temperature in a different way. We'll get into that whole other story. We don't need to do a lecture on scrotums. Okay, and they are, again, through recent studies, have extremely close genetic relationships with modern dugongs on a comparable level to humans and chimpanzees. And that's kind of cool. So, and we have only known this since the 90s and the 2000s. And again, it takes time for these things to get into the school books. So people might have been taught in the 80s that the dassie was the closest, but the school books are still catching up in the curriculum because the guys that learned this at university are only now compiling the school books for the next generation. So, and for the university books for the next generation. So sometimes things are recent discoveries and they make the news, but they don't get put into the textbooks until 20 years later. So things you know are probably horribly out of date. That's why it's important to keep up with books. And again, just like a tapir, the elephant's trunk is a fused upper lip and nose. That's all it is, nothing fancy. So going back 35 million years ago to Moratherium, we have this and a descendant of his called Paleomastodon. And he was around from 35 million to about 25 million years ago. And he was a very, very primitive-like elephant. His trunk would have been very short, looking at the structure of his rostrum. And we would have been able to recognize that he probably had a very short trunk. We don't know because it was flesh material and doesn't preserve in the fossil record. It might have been bloody long. But there's no indication that it would have been long. There's an indication that it would have been a short structure like a tapir's. And he had very, very small dentition and tusks. And in terms of his size, not much bigger than a large cow. That's pretty much what you're looking at, a large cow in terms of size. And he was very successful throughout Africa. And he evolved from wetland conditions. He would have been adapted to living in swamps, and gradually he would have been living in more forested areas over time. Over time, Gomphotheria evolved, and he was comparable to the size of an Asian elephant, but again, very primitive. He would have had, he had upper and lower canines, tusks, but they were very primitive in their structure, not very developed. They tend to be quite wonky. And he had a very flat skull, indicating that he would have probably been more of a wetland specialist and less developed to pushing over large trees and competing over with other large animals, unlike our modern elephants, which have got these ramming skulls because they're perfectly adapted for pushing over trees and ramming each other and cars. So, but for all intents and purposes, he was almost identical to a modern elephant. You could not confuse this for anything else. And that rapid evolution happened, well, not rapidly, but it happened over 10 million years. So you had this massive transformation from a hippo-like creature to an elephant-like creature in about 10 million years. Talking about wetland specialists, one of my personal favorites and probably the weirdest is a particularly weird elephant called Platy Belladon. And he was around from 15 million years ago to 10 million years ago. He's not an ancestor of modern elephants. He was another species on his own evolutionary trajectory, and they went extinct. So he's not related to he's not truly related to modern elephants, just like your 13th cousin is not related to you. He is he's got the same ancestry as you, but he's not your direct relative. He's got an ancestor somewhere along the line that you have. And Platy Belladon was like that. He was a distant cousin of elephants, but he was not a direct descendant of our modern African elephant. And this is what he looked like. And again, small tusks, a very small proboscis, a trunk, and those large scraping teeth indicate he was probably a wetland specialist, scraping on marshy foods. And he's just a really weird looking animal. But yeah, lots of fossils have been found. Those teeth are not fake. It looks ridiculous, but he was around for 5 million years, far longer than humans have been around for. And he was obviously very good at what he did. So gradually, by about 5 million years ago, and this is hitting close to when humans were starting to appear on the scene. Modern hominids were starting to appear on the scene about 4 million years ago, Australopithecines, and their ancestors appeared about 3.5 million. So this is getting close to the age of humans, hominids, not true humans. So 5 million years ago, the modern elephants, Primaelephas, which just means the first elephant, appeared on the scene. He was, again, pretty much the size of a modern elephant. And we had this magical diversification happen. What happened was the elephants were starting to become more and more adapted from riverine environments to more savanna and forest environments, and they started venturing out of their territories. And of course, they started venturing out of Africa into Asia. And then we started having this massive diversification happen. So the new expansion of elephants into the old and the new world from the recently accessible African continent created a range of habitats and thus diversification. And of course, because they're isolated, they had this evolution, genetic drift happening as well. So just general appearance changed, even though it didn't really affect their survival. So if you happen to live on the opposite side of the continent, you'll gradually evolve to look different to someone else on the other side of the continent because you're just not sharing the same genes, and your genes are mutating independently with no interaction. So 3 main families appeared. So the Stegodons, which thrived throughout Africa and Asia, and they were very successful until fairly recently, probably about 20,000 years ago. Sorry, until 40,000 years ago. The Mastodons, which thrived in North and South America until yay us. And of course the elephants, which are still around today, although they're not doing as well as they used to do. Now remember, there were numerous species, but remember, the larger the animal, the lower the diversity, because small animals adapt to very specific environments, and large animals tend to adapt to a very general environment over large terrain. So they don't have that much diversity. So although there were dozens of species of elephants, they were not as diverse as, say, rodent species or bat species, because they're gigantic and they're crossing everything from tundra to grass and to desert to jungle with one particular animal. So here needs to be a generalist. So you don't have these, you won't have thousands of elephant species like you do rodents, for example. So Stegodons had these beautiful, gorgeous tusks, always curved, and they were around from 11 million years ago, and initially evolved in Africa, thrived throughout Africa, and then later species evolved in Asia. And they were really, really successful, and they started to disappear the moment modern humans appeared in Asia, and the last species also were hunted out where they occurred in parts of Africa where human tribes were thriving. But they're pretty much, their benchmark was in Asia, and again, most humans arrived in Asia, they wiped them out. So the modern elephants, of course, are, sorry, did I jump something? I think I jumped something. Yeah, sorry. And mastodons, which occurred in this, sorry, I made a mistake of rearranging this. Mastodons, which are not related to elephants as in the true elephants, they were elephantids or proboscideans, and they thrived in North America from about 5 million years ago until about 11,000 AD. The moment Native Americans arrived, this one's for you, Ian, we talked about this. The moment Native Americans arrived, they wiped them out within 1,000 years. All the species of mastodons that occurred there. The word mastodon literally means nipple teeth, because he had teeth that kind of look like nipples, so they called them nipple teeth. Scientists are very uncreative. Okay, so the modern elephants, until recently, 3,500 years ago, there were 3 genera of elephants. There are now 2. Okay, so 3,500 years ago, to give you some perspective, at this time, the pyramids of Giza, everyone wants to go and see them, they were already 1,000 years old when there were 3 genera of elephants. Okay, so human civilization was going well, and there was a whole other species of elephant occurring that was thriving. So there was the Loxodonta, African elephants. There are 2 species alive today. There's Elephas. Elephas maximus is the only one. That's the Asian elephant. There are 6 subspecies, not different species, just the same species, but subspecies. And of course, there were, until 3,500 years ago, the mammutus, the mammoths of Asia. And the moment that the human tribes, they were had pressure over them for the last 50,000 years. The last of them was surviving in Siberia until 3,500 years ago. And the moment the tribes arrived in Siberia 3,000 years ago, 3,500 years ago, good night, Zaijian and Sayonara. They were gone. So, yeah, mammoths. Fantastic, and we'll talk about that shortly. So Mastodons, not related to mammoths. This is a bit of a rearrangement issue. So the largest elephant to have ever known to exist was Paleoloxodon namidicus, and this was the Asian straight-trunked elephant, an absolute monster, larger than many, many dinosaurs, about 5.2 meters tall, to give you an idea. He was about 22,000 kilograms. An African elephant, a big African elephant, is about 7,000 kilograms. So this guy was 22,000, and he was around until about 100,000 years ago. And climate change was a major factor. The end of the ice ages, he would thrive in icy, cold environments. And remember, we talked about cold and hot affecting the size of animals. And with increases in global temperatures, he had pressure with smaller elephants species, and of course with human tribes putting pressure on him, and the evolution of dogs also putting pressure on their habitat. It just gradually went extinct. So the Asian straight-tusked elephant, unfortunately, is no more, but the largest elephant to have ever exist. Pretty big animal. So Loxodonta has two species, the African bush elephant and the African forest elephant. We're going to get into the next lesson. Elephas has got one species, the Asian elephant, 6 subspecies, and until 3,500 years ago, mammutus, the woolly mammoth. And to give you an idea of how recent this was, again, this was 1,000 years after the pyramids of Giza, but they're still digging up frozen woolly mammoth. These are not bones, this is meat. You could technically eat this because it's been frozen in the permafrost of Siberia and Asia for the last couple 10,000, 30,000 years. So again, they died out 3,500 years ago, but they've been around for hundreds of thousands of years. And this was a little elephant, baby mammoth that they dredged up. I think he was about 30,000 years old. And interesting story, a Siberian husky actually ate his tail when they dug him out. So he's preserved in a museum. He's currently in Australia, I think. And this was another guy that dug up recently. He's about 39,000 years old, still covered in hair. Okay, so these are not dummies. These are just permanently frozen permafrost woolly mammoth babies. Now, really cool story is that we might just see the woolly mammoth back. It's not science fiction. There's a place called Pleistocene Park. There's the email. There's the website there, pleistocenepark.ru. This is a legitimate project. Scientists at the park are attempting to clone woolly mammoths using Asian elephants as surrogate parents. Yes. So the Asian elephant is the closest relative of the woolly mammoth. They've got ample genetic material, as you've been seeing from the photos. They take the cells, they do their magic. I'm not sure exactly how, but the same way they did Dolly the sheep, and they are planning to clone woolly mammoths. They have ample stock, and they state that they will have successfully cloned mammoths in the next 2 decades. This is not playing God, as people say. Remember, we wiped them out. We're almost under an ethical obligation to bring them back. But on top of that, mammoths were integral to the steppe ecology for millions of years, and only in the last 3,500 years, they're gone. So the steppe habitats are collapsing because of this massive ecological vacuum that's been created because of humans. We've created a form of environmental damage, and we're now, the scientists are saying, actually, we need to bring mammoths back to restore the ecology of the Siberian steppes. So, fun fact, hopefully by 2050, we'll get to see woolly mammoths again. So let's hold fingers. We're going to get more into modern elephants, as in Asian and African elephants, next lesson. But this Pleistocene Park is a place. They've reintroduced a lot of species that have been driven to extinction in the area, but they've brought them back through breeding programs. No truly extinct species yet. The mammoth is the keystone species they're working on. So, to be continued, anyone that wants to do Q&A, I'm having Q&A after this at 8 p.m., same time or same address, same, same password. If you guys want to ask you questions, if you don't want to come for the Q&A after 8, you're more than welcome to ask me questions now. Any questions? What is the size of the reserve? I have absolutely no idea. I think 8,000, but I don't know. And again, it's very difficult because they have preserved areas which is government demarcated, but then also Siberia is just vast wilderness. So you might have a couple hundred or a couple thousand hectares, but actually realistically is tens of thousands of hectares because no one lives there. It's Siberia. There's like 2 people in the whole area. Most of the farmers there are reindeer farmers. To answer Mo's question. Any other questions, guys? Nope. Nope. Hello? No, I was referring to the reserve you were working. Oh, my reserve. Sorry. The reserve I'm working on at the moment is about 5,000 hectares. So we're expanding it to 5.5. We've got access to about another 4,000, but just funds are an issue for fencing. So when we can afford the funds, we'll fence that other 4.5. And we've got plans for expanding to a much bigger reserve in the future. We're just trying to work with the local chiefs and the Zulu chiefs. Tula Tula, so I work at Tula Tula. I'll write the name there. Tula. It's just outside of Mpangeni, 20 minutes drive outside of Mpangeni. So the biggest size of African elephant ears is because of the warmer climate. No, Asian elephant's climate is just as hot. I mean, if you've ever been to India or Sri Lanka, it's 42 degrees in summer. It's just a part of the evolution. It's some things evolve, something evolves. You might find that African elephants initially evolved larger ears because it was sexually preferred by females. They were more impressed with bigger ears. And over time, it's evolved into the gene pool, but in a secondary role. But it just happens to be that African elephants have large ears. But no, Asia is much hotter than people realize. It's, you know, so you're getting 90% humidity with 42 degrees, you just die. So and that's possibly one of the reasons why Asian elephants might be even smaller than African elephants, because that humidity level takes it to a whole other place. Any other questions? Where are dugongs? Dugongs and manatees are found all over the world. We're going to be doing we'll do them included in the next elephant lecture. I was just not trying to bore you because I know everyone's keen to talk about elephants. I'm not sure if the speakers are working. But yeah, so dugongs and manatees are live predominantly of seagrasses along the sandy shore oceans around the world. They're found in Florida, Mozambique, Madagascar. You occasionally find them around South Africa. They're found historically throughout Europe as well, although I think they're all hunted out in those areas. Yeah, so anywhere where you have saltwater grasses growing, you have underwater seagrasses. That's where you get manatees and dugongs. And again, they're not in any way related to seals. They just have this evolutionary convergence. So just a heads up, who's keen to do the Q&A after 8? Otherwise, I'm, to be honest, not going to do it. Is there anyone keen to do it? Just put your name over here in the chat message, just to let me know, and then we can do a Q&A. Otherwise, we'll just call it a night. Nobody? Nobody at all. Have to gap it, sorry. All right then, guys, then if no one's going to start coming in for the Q&A, next week, class will probably be Friday or Saturday. And if you have a few questions, you're more than welcome to WhatsApp me. You've all got my WhatsApp number, or email me. And thanks for popping by. I hope it was informative. It was a bit rushed this week, I know, and my weeks are always rushed, to be honest. I had to compile that just this afternoon. But yeah, get that book, The Living Elephants. If you can find it, it's worth getting. So I hope you enjoyed it, and please, I love questions, so if you want to ask questions, ask questions. Thanks, guys. I shall see you next week. Auf Wiedersehen, adios, arrivederci, bon voyage.